This video will talk about summation notation. We'll describe quantitative data with numerical measures. We'll discuss the meaning of the symbols involved with sigma. The important terminology for this section will be summation. Summation is the sum of the measurements or observations whose typical member is x sub I, beginning with the member x sub 1 and ending with the member x sub n. We use the Greek symbol sigma to represent the sum. So above you can see the sigma, and there are other variables written around that, and we'll talk about what those represent. Subscript is a number or a letter that's written below our term, slightly below. So x sub 1 represents the first measurement in our observation, while x sub n represents the last measurement. So if you don't know how many measurements there are in the data set, we're using n to represent the last value. Variable is the symbol following the summation sign, and it represents the variable or function of the variable that is to be summed. The lower limit is the initial data measurement to be included in the summation. So that just indicates which data point we are starting with. It doesn't necessarily mean it's the first number in the data set. It's just your starting point. Upper limit is the final data measurement to be included in the summation. So again, it's just telling us which data value we are stopping with, not necessarily the last value in the data set. Index of summation, that is written below the sigma symbol. I equals 1 indicates which measurement to start with. So in this case, if I equals 1, that means start with the first measurement in the data set. Now let's see how we can put all of this together and work out a few sample problems. Here it says, suppose a data set contains the observations 6, 0, -2, -1, and 3. So you can see we've got sigma x. That means the sum of all the x values in the data set. So we have 6, 0, -2, -1, and 3. That means we're going to add all of those numbers. Sigma x represents finding the sum of x. So we're adding all of the data values together. 6 plus 0 plus -2 plus -1 plus 3, and that equals 6. For part B, the summation of x squared represents taking each x value in the data set, squaring it, and then summing it. So it's important to know, square each value, then find the sum. So it might be helpful to construct a table of your x values, and in the column next to that, your x squared values, and then it would be easy to find the sum. Now that we have a table with our x values, we can square each of those x values. 6 times 6 would be 36. 0 times 0 would still be 0. Now be careful with -2. The negative and the 2 are included in the squaring, so you actually have -2 multiplied by -2. The result is +4. The same will occur with the quantity of -1. So quantity of -1 times another -1 would make +1. And finally, 3 times 3 would give us 9. So to find the sum of the x values resulted in 6. So we'll need to add up 36 plus 4 makes 40, plus another 1 plus 9. So 40 plus 10 would make 50. 50 is the sum of the x squared values. For part C, we have the sum of the quantity x plus 4 squared. So it's important to apply the order of operations here. We must take our first data value, add 4, square that amount, and then we will find the sum. So I could actually just continue with the previous table and add a new column for the sum of x plus 4 squared. Now that we have a column for the quantity of x plus 4 squared, we're going to substitute each data value for x, one at a time. So our first observation of 6 would mean the quantity of 6 plus 4 squared. So that would equal 10 times 10, or 100. Our next data value of 0 would mean 0 plus 4 times the quantity of 0 plus 4, and that would equal 4 times 4, or 16. The next data value is negative 2, so we have the quantity of negative 2 plus 4 times the quantity of negative 2 plus 4. So we have actually 2 times 2, which is 4. The next data value of negative 1, we have negative 1 plus 4 times the quantity of negative 1 plus 4, and that would equal 3 times 3, which is 9. Our last data value is 3, so that means we have the quantity of 3 plus 4 times the quantity of 3 plus 4. So that turns into 7 times 7, or 49. Remember, this last row is where we're writing our sum. So the number we're going to write for the sum of the quantity x plus 4 squared comes from adding 100 plus 16 plus 4 plus 9 plus 49, and that total is 178. You might find it helpful to organize a table so that you have your data points right there available to square or to substitute in any way that you need to. And our next example, part D, is asking us to find the summation of the quantity x minus 3 squared. So I'm going to go back to the table and add a new column for the quantity of x minus 3 squared. Our column is all set up to fill in. Again, we're replacing each observation for x. So my first calculation is actually 6 minus 3 times another quantity of 6 minus 3. So 6 minus 3 is 3 times 3, that would equal 9. The next observation or data value is 0. So I'm substituting 0 minus 3 times the quantity of 0 minus 3. So this time, negative 3 times another quantity of negative 3 will also make positive 9. Our next observation is negative 2. So negative 2 minus 3 multiplied by another negative 2 minus 3 quantity makes negative 5 times the quantity of negative 5, which would be 25. Negative 1 is our next observation. So the quantity of negative 1 minus 3 multiplied by another quantity of negative 1 minus 3 will result in negative 4 times negative 4, which would be positive 16. Our final data point is positive 3. So we'll have 3 minus 3 multiplied by another quantity of 3 minus 3. So that would be 0 times 0, and that makes 0. So the next thing to do, we're going to fill in the last row here with the summation. So we're adding 9 plus 9 plus 25 plus 16 plus 0, and that makes 59. So again, you might find it helpful to construct a table. So we have our last row, the summation of x. The summation of x squared is 50. The summation of the quantity x plus 4 squared is 178. And last, the summation of the quantity of x minus 3 squared is 59. For part E, we are looking for the summation of x squared. So notice the parentheses. When we have parentheses, that means we're going to sum all of our data values or observation and then square that result. So we're going to sum all observations, then square the result. So if we look back to the table, the sum of our observations is 6. Sum of all x is 6. Therefore, 6 times 6 is 36. So the summation of x, quantity squared, is equal to 36. So now for the final problem, the sum of x squared minus the quantity of the sum of x squared divided by 5 is just using some substitution because we've made these calculations already. The sum of the x squared values was equal to 50. The sum of the quantity of the sum of x squared in the previous step, that was 36. So we know that we are subtracting a fraction that is 36 divided by 5. So I'm going to start with 36 divided by 5, and that is 7.2. and all we have to do is subtract 7.2. So we now know that we can start with 50 and subtract 7.2. 50 minus 7.2 is equal to 42.8, and that is our final answer.